All right, today we're diving into something pretty wild. It's a brand new cyber attack, an incredibly clever one that can bring down the world's most powerful AI systems. And the craziest part? It doesn't use a massive army of bots. It just uses a few very specific words. Let's dig into how they pull it off.
I mean, it sounds impossible, doesn't it? How on earth could a simple text prompt make a super advanced AI just get stuck in a loop, thinking forever until it basically breaks itself? Well, that is the exact question we're going to unpack.
And look, this isn't just some theory someone cooked up. This comes from a seriously impressive research paper that's going to be presented at the NDSS 2026 Security Symposium. That's a huge deal in the security world. And what it reveals is a fundamental weakness in the very AI tools that we're all starting to rely on every single day.
So, to really get a handle on this, we're going to frame it like a heist. And, every great heist starts with a high-value target.
Our targets are the AI services you probably use all the time. These are like our digital vaults, holding just an immense amount of computational power. And behind these services are what we call large language models, or LLMs. They're the engines making it all happen.
But here's the thing. These vaults are locked up tight. They're what's known as black box models. You can send a prompt in, you can get a response out, but you have absolutely no idea what's going on inside. The internal schematics, the code, the logic, it's all a total secret.
So, the goal of this particular heist isn't to steal any data. It's a denial of service attack. The whole plan is to craft one perfect little prompt that tricks the AI into an endless loop, basically sucking up all its brainpower until it grinds to a halt or just crashes for everybody else.
Okay, so how do you possibly crack a vault when you can't see the lock? When you have no idea how the mechanism works? That is the core challenge these researchers had to solve.
On the left here, you can see the old way of doing things. These attacks needed some kind of inside knowledge, they were expensive, and they were often pretty easy to spot. But on the right, that's the world we live in now. The black box is sealed. You have zero inside access. So any attack has to be cheap, reliable, and work from the outside.
And this is where things get really, really clever. To solve the seemingly impossible problem, the researchers came up with an incredibly elegant master plan. They call it ThinkTrap.
The first brilliant move is to completely change the landscape. You see, LLMs see language as these separate, clunky blocks called tokens. Think of it like a jagged mountain range made of Legos. Trying to find the lowest point is really hard. ThinkTrap instead smooths that whole landscape out into a continuous map. Now, finding the weak spots, the valleys, is suddenly way, way easier.
And the second part of the genius here is that they don't even try to search that whole massive, smooth space. The attack narrows its focus to a tiny, tiny slice of it. It's the difference between trying every single number combination on a vault lock versus knowing you only need to turn 3 specific dials to pop it open. It makes the whole process unbelievably efficient.
So how does it actually work? Well, it's this clever loop. First, it takes a starting prompt and projects it into that small, efficient space. Second, an algorithm optimizes it, looking for a better version. Third, it decodes that result back into a real text prompt. Fourth, it sends that new prompt to the AI and just measures how long the response is. And finally, it learns from that response and repeats the whole cycle, getting smarter and closer to the perfect attack prompt with every single loop.
So, the plan is set. The master key has been forged. Now it's time to see what happens when the ThinkTrap heist actually goes down. And the impact is just staggering. With just a few of these special prompts, the attack can cripple a service, reducing its ability to handle requests, what we call its throughput, all the way down to just 1% of its normal capacity. And what does that feel like for a regular user? Well, your wait time for an answer can shoot up by 100 times. A service that was once instant now feels like it's wading through mud. It becomes practically unusable. And in the worst case, this is the ultimate result. The attack can push the AI so hard that it literally runs out of brain power. It exhausts its GPU memory, the very resource it needs to think. The service doesn't just slow down, it fails completely. The vault isn't just locked, it's broken.
Maybe the most dangerous part of all this is how stealthy it is. This isn't a loud, brute force attack that's easy to spot. We're talking about a quiet, surgical strike, just a few requests per minute. It's designed to fly right under the radar of most security systems.
So, a heist this successful, well, it changes the game. What does this discovery actually mean for the cat and mouse race of AI security?
You don't have to take my word for it. The researchers themselves put it pretty bluntly in their paper.
They say that ThinkTrap highlights a new class of realistic threats to large-scale LLM systems. This isn't just some minor bug. It's a whole new category of problem.
And defending against it? Wow, it is incredibly difficult. Your typical anomaly detectors don't work because the attack prompts aren't repetitive. They're all unique. And sure, you could just limit the resources any one user can have, but that directly hurts the real people who need the AI for complex tasks. It's a painful trade-off with no easy answer.
Which really brings us to the big final question. We're in this massive rush to build bigger and smarter AI every single day. But is the foundation we're building it all on actually secure enough to handle the very intelligence we're creating?